Dear students, welcome to Statics and Dynamics with me, Dr. Loay Al-Zube. We are continuing our discussion of principles of moment. We have completed 2 videos before this video. This is the 3rd video in this lecture, and we're going to solve problems. So we're going to start with a 2-dimensional problem in which we're going to do determine the moment of a force using the scalar formulation. So for this example, we are going to analyze the system. So we have a 100 Newton force is applied to the frame as seen here, and we would like to find the moment of the force around the point O. So we need to look at what's the approach that we're going to follow in order to find the moment around point O. And remember, this is a 2-dimensional problem, so it's always a good thing to see if we can break down the forces into 2 components. Now remember, the moment to calculate the moment formula is m, the magnitude, equals to F multiplied by D, and we need to make sure that D is actually the perpendicular distance between the point around which we would like to find the moments and the line of action of the force. So the force is given to us by 100 Newton, and it has an angle given by this, right hand triangle. And we have these 2 distances, the 5 and 2 meters. So what is the plan? First, we need to resolve the 100 force along the X and Y component. So we know that we can resolve F into, this is the X component, and this is the Y component based on the direction of the force. And we know that the X component is going to be 100 multiplied by the parallel over the hypotenuse, which is 4/5 parallel to the x-axis, and the y component is 100 multiplied by 3/5, and this is your Fy, right? So we have these 2 components. So that's the first thing we need to do. Then we need to find the moment using a scalar analysis for the 2 component forces, and then add those 2 components together. We need to find the distances. So remember that the distances has to be perpendicular with the line of action. So for the f of x, the distance between the point and the line of action is this distance, right here, which is 2. And for the line of action of the y, this is the line of action of the y, the perpendicular distance is this one here, which is 5. Remember that the moment has a sense of rotation. So for fx, it's going to rotate around it, clockwise, and for fy is going to be clockwise. That's fy. So we're going to look at these in more details. So this is what's going to happen. This is your Fy, as we talked before. So the Fy is going down, right? And that's negative. So that's 100 multiplied by the perpendicular, the parallel, so 3/5. That's what we have, and that's in newtons. And our f of x is going to be positive, right? And because that's a positive x-axis, that's our notation. That's up y, and this is to the right x, and that's 100 multiplied by 4/5, and that's what we have here. Now the moment, we're going to assume that the rotation counterclockwise is positive. That's what we have here. And so if we start with the y component, so this is the line of action, right, of the y, and I have the distance between point O and the line of action, the perpendicular distance is 5. So we have minus 100 divided by 5/3 multiplied by 5, and it is negative here. And if we are looking at the x component as well, so we have, this is my line of action for the x, that's the distance between the x line of action and the point, perpendicular distance, which is 2. So we are looking at also the force. It's going, so the rotation is going to be clockwise as well. So that's why we have minus 100 multiplied by 4/5 and multiplied by 2. and when you have them all together, right, you will end up with minus 460 Newton meter, and we can say that this is 460 Newton meter clockwise. And this is how we solve a two-dimensional problem and to determine the moment of a two-dimensional case or problem. I hope that was helpful, and till next video. Bye.